Okay, here we go. 2.2 is finding slope and rate of change. Okay, slope. We know that slope is change in y over change in x. I know you know that. Okay, which means it's also known as rise over run. If you see this little lowercase m, that stands for slope. Okay, they're going to use that a lot in this textbook. I don't know how familiar you are with that, but that is what slope is. Okay. So, just like a little warm-up question, I'm going to add more to it after we create an equation, okay? It says a skateboard ramp has a rise of 15 inches. What is its slope? Okay? It has a rise of 15 inches. How can I set up an equation for that? How can I set up an equation for that? 15 over x. Okay, so good idea. Slope equals 15 over x because I don't know what I know what my rise is, but I don't know what my run is yet, correct? Okay, so what is its slope? Well, we need more information, so I'm going to give you more information. Let's say that it's a run, okay, of 54 inches. What would I do to solve that now, to find the slope? Yeah, good. She says 15 over 54 and simplify. What can go into 15 and into 54?
5.
Oh, 3.
3. 3. It's okay. 3 goes into 15 5 times. 3 goes into 54. How many?
18.
18. David was 17, 19.
Somewhere.
Yeah, 18. So my slope is 5/18 in this case, okay? That's one way we might have to find slope, through kind of a word problem like that where you set up an equation yourself and then they'll give you more information you can go off with it. Okay, bless you. What is the slope of a line passing through the points -1, 3, and 2, -1? How do I set that up?
I think y
do
over
the-
x.
Change in y over change in x. So I'm going to say -1 minus 3 over 2 minus -1. Okay? What do you get up top? -4. And on the bottom you get 3 because it is a big number. So I have a -4 over 3. That's what my teacher called it. What, Alex?
Can't you do the thing?
Where you draw it out?
Yeah.
Yes, you can do that.
I like that one better.
Okay, that's how you want to do it. You do it that way. Okay. Classification of lines by slope. There are 4 types of classifications we get for lines by the slope. We have a positive classification where it rises from left to right, correct? We have a negative slope where it falls from left to right. We have a 0 slope, okay, which means it is a horizontal line. And a 0 slope means that if I were to solve, it would have 0 on the top of the denominator. 0 over 7, 0 over whatever. Undefined slope is a vertical line, okay, and its slope means that it has a 0 in the denominator. That's why it's undefined, because we can't have zeros in our denominators, okay? Can we handle that stuff so far? Any questions on that? Nope, we good? Okay. So then we're going to get to parts in our homework where it says, without graphing, okay, without graphing, tell whether the line through the given point rises, falls, is horizontal, or is vertical. So if I'm not graphing it, what do I have to use?
Your brain. Picture it.
What? Yeah, the slope formula. So here I'm going to set it up. How do I set up this slope formula? What do we want to put up top?
Minus
1 minus 1 over what?
3 minus
3 minus negative 5, and you get what up top?
0
And you get what on bottom?
over
8. What type of slope is that when I have a 0 on top of my fraction?
8. Undefined.
Undefined.
0 slope.
It's a 0 slope. It's a 0 slope. Okay? It's horizontal, which means it's horizontal. 0 equals horizontal. So with this set of directions, we should be answering it's horizontal. Okay? Next one. Tell me, how do I set up this slope?
8 minus 3.
8 minus 3 over?
5 minus
Good. So 8 minus 3 is?
5.
And 5 plus 1?
6.
6. And what type of slope is that?
Positive.
Positive, which means is it rising, falling, horizontal?
Rising.
Rising, okay. It rises.
I wanted to be the first one.
Okay, next one. How do I set it up? Quick.
-1 over
Minus 6 and then 4 minus 4. And you're going to get negative 7 on top, and you're going to get
Undefined.
0, which is undefined, which is what in this case? Vertical. Okay. And of course, I show one of every one. So the last one, we know what it's going to be. But let's say negative 4 minus 0 over 2 minus negative 6 gives me negative 4 on top and gives me 8 on bottom, which gives me negative 1/2. Always reduce your slopes. What is negative 1/2 then? Is it rising, falling, horizontal, vertical?
Falling.
Falling. Okay. You're going to have to classify a bunch of those on your homework tonight. Okay. The last thing we're going to hit with slopes is parallel and perpendicular lines, because their slopes tell me if I'm comparing two lines, slopes tell me if they're parallel to each other, if they're perpendicular to each other, or if it's neither. Okay. What does a parallel sign look like? Maddie goes like this. Yes, it's just two lines like this, like two L's or an 11, okay? So if you see that terminology in your book, that stands for parallel lines. What would parallel lines be drawn like? What does it mean when I draw parallel lines?
They never intersect.
They never intersect, so they can go diagonal, they can go up and down, they can go horizontally, they just cannot intersect, okay? So those ones are beautifully perfect, okay? When you see this, let's go ahead and I'm going to label this 1 and 2, okay? And so I'm going to say the slope of line 1 is equal to the slope of line 2 when I have parallel lines. So when I have parallel lines, the slopes are the same, okay? If you need that in number form, it would be something like this. If I have 3/5 as a slope, it would also equal 3/5. The slopes are the same. Okay. Perpendicular lines. What is the symbol for perpendicular lines? Like an upside down T, yeah. Creates a 90-degree angle. And then Alex showed me what it would look like on a graph. Let's go like this. Boom, boom. Okay, 90-degree angle right there. That is perpendicular. Perpendicular lines, what do we know about their slopes?
They intersect.
They're what, David? Negative reciprocals. So if my first slope is just that, my second slope would be the negative reciprocal. In number form, that would be 3/5 equals negative 5/3. What happens if it's negative 1/2 equals something? What would be the negative reciprocal of negative 1/2?
Just 2.
Just 2. Just 2, okay? So you need to remember that when you're dealing with perpendicular and parallel. Now, in your homework, there's also a section, our book likes to do this type of section, where it says, here are the lines parallel, perpendicular, or neither? And it just says line 1 and line 2. How can I go about solving that? What do you think I need to do to figure out if they are parallel or perpendicular? Yeah, let's do it without graphing today.
You can do top and the bottom. Top
I don't know what that means.
and the bottom. Wait. You can just do the same.
Find the slopes. Find the slopes of each line. So yes, you will have to show me work, and yes, there is work involved with this. I know, what a pain. So line 1 would equal, the slope would be 1 minus 2 over 0 minus negative 2, which would give me negative 2 over 2, which gives me what? Oh, not negative 2, I'm silly. Gives me negative 1/2. Guys, catch my math. Come on. And line 2 would be what? 3 minus negative 1 over 2 minus negative 4, which would give me 4 over 6, which equals, what's that reduced to?
2/3.
2/3. Are they parallel, perpendicular? Neither. Neither.
No.
Okay. L1 down here.
They're perpendicular.
Okay. Let's do the math. Negative 3 minus 2 over 4 minus 1. What's negative 3 minus 2?
1, negative 1.
No.
Negative 5.
Negative 5. Over 4 minus 1 is 3. So I have negative 5/3. And then line 2 is negative 2 minus 3 over negative 1 minus negative 4. Negative 2 minus negative 3 is negative 5 over 3. And those would be what? Parallel. Okay. Last thing we need to touch base with is this. It says that a slope can be used to find an average rate of change or a quantity. Okay? So slope can be used to find those things, an average rate of change or quantity. Sometimes they measure weather stuff like the average rate of change of rainfall over the course of a period of time or over the course of years. This problem we're going to do, these little circles represent like a tree trunk that's growing, so average rate of change of that tree over time. Okay, so we use this in real world scenarios. The way they find it is by using slope. Okay, so it says use this diagram to find the average rate of change over time of the tree. Then predict the diameter in 2065. So this tree back in 1965 had a diameter of 137 inches. Now the tree in 2005, when they remeasured it, had a diameter of 141 inches. How can I figure out what the average rate of change is for that tree?
Set up a proportion.
No, not proportion. We have to use slope, but what are my points for the slope? What's my x? What's my y?
Oh.
Years of the
Good, Maddie.
And diameter.
Okay, so time is going to be my x, okay, and my y is going to be my diameter. So I'm going to take, to find that slope, I'm going to take 141 and subtract from it 137. Then I'm going to take the year 2005 and subtract from it the year 1965. What do you get when you subtract 141 from 137? What? You had it right. 4. You get 4 inches, because technically this top part's in inches and the bottom is in years, right? What do you get when you subtract 2005 from 1965? Or you get 40 years. So, reduce it, and I get 1/10, or 0.1, right? So I'm going to get 0.1 inches per year, correct?
Yes.
Now, how can I predict the diameter in 2065? What?
Oh, you do that.
Okay, what?
0.1 times 60 and then add it to the.
Okay, Maddie says 0.1 times 60 and then add it to what?
Add it to 140.
Okay, where did you get 60 from, Maddie?
Because 2005 plus 60 more years would be 2006.
Okay, because she took the last set of data we know of and figured out the difference of years it was, which is 60. So she's multiplying 60 years times the rate of change we found already, which is 0.1, and adding it to 141. So you get 6 plus 141, which would give you a diameter of 147 inches in the year 2065.
Where did the tree die?
Too bad.